All right, now let us talk about states of matter. You see, based on physical properties of matter, matter exists in three important states according to O-level chemistry. So now, the three states of matter or phases of matter, we can either call it states or phases of matter. So these are solid states, liquid states, and gaseous states. Now, any matter that is in its solid state, we say that that substance is a solid. So we say that such a substance is a solid. Then any substance or any matter that is in its liquid state, so we say that such substance is a liquid. So, and finally, any substance that is in gaseous state, so or any matter that is in gaseous state, we say that such a substance is a gas. So now, this is according to O-level chemistry. We have three states. We have solid, liquid, and gas, and these are called states or phases of matter. So now, let's consider the properties of each one of them one after the other. Now, let's talk about solid. Solid generally can be identified by their rigid shape. That is, they always have structural rigidity due to the closeness of the particles that are contained in the solid. And this is one of the things that offer them definite shape and volume. So now we can generally list some properties of all solid. Let's consider it in the following list. Or before that, let's consider some pictures of solid, how they look, and how we always represent their molecules in chemistry, how the molecules are closely packed. Let's see that. So now consider the pictures of some solid materials here. Now consider this. This is the general structure of all solid. So all of these spheres that are attached to each other, they represent the particles of solid. You can see how close they are. They are very closely packed. So this is what offers every solid their rigid shape. So this is another one here. You can see the closeness of the particles. So this offers them the rigidity that they have. It makes them very rigid, and it doesn't allow them to flow like liquid. So that means solid particles can only vibrate. They cannot flow like liquid. So now in this other image, we have stone. Stone is solid. We have metals, we have cotton, we have wood, we have sand, we have coal, we have gold, and we have clay. All of these are solid material. Look at this. This is glass. I'm sorry. This is a glass. So it's also a solid material. Then look at this: metal, glass, plastic, fabric. We have concrete, we have wood, we have ceramic, we have rubber. All of these are solid materials because they have the same general property, which is rigidity. So that is how solid materials look. So all of these are solid. We get them from different sources. Let's now consider some general properties of solid. So here is the list of some of the properties of solid. The first one is solids are generally rigid. Of course, all the solid that I showed above, they are rigid because they have rigid shape, and that's actually due to their molecules. The molecules are close together, they are closely packed, so that there is no space in between them. So now look at this: solid have definite shape. So they have definite shape. So it can be cylindrical, it can be spherical, it can be circular, it can be rectangular, it can be cuboid, it can be cube, and so on. So they must have definite shape. Then another thing is that they have definite volume. That is the capacity of liquid that can fill up the solid. So they have definite volume. And we can always calculate the volume by either using a formula or using an instrument to measure the volume directly. Then we have the particles of solid are closely packed. Of course, if I go back to the top and show you how it is, you will see that they are actually closely packed. So watch what we have here. See the particles, they are very close together such that there is no space between them. And this is what is responsible for their rigid shape and also the volume. So another one is that the force of attraction between the particles of solid is very strong. So the particles of solid, that is their molecules, the force of attraction between them is very strong, and that's why they have rigid shape, and that's why they also have that's why they have definite volume, because those particles are close together. They are holding one another with strong force of binding, strong force of attraction. Then followed by the particles of solid can only vibrate. Of course, that's due to their strong force of attraction, and that's why they cannot flow like a liquid due to their strong binding force. So they cannot flow like liquid. You cannot place a glass down now and expect the glass to start flowing like water. So because it has rigid shape. And finally, due to that, they have low kinetic energy. Kinetic energy is the energy that we need for movement. So due to the fact that these molecules are holding one another tightly, so they are not free to move. So that means they have low kinetic energy. Another one is solid diffuse very slowly. Diffusion simply means movement of their molecules. So because the molecules cannot move freely. So their rate of diffusion is very low. They diffuse slowly, very slowly. And finally, solid are not compressible. So because we cannot compress solid inside a container unless if the container is the same size as that solid. Unlike gas that we can compress it inside a container. It's not possible for me to compress solid inside a container that is not its size. So it's either the solid gets broken or the solid breaks the container. So if we try to force it inside. So that's why solids are not very compressed. They are not even compressible at all. So after this, let's consider liquids. So now all of these images are examples of liquid substances. So look at this first image. We have a list of Nigerian drinks. So we have Pepsi, we have Coke, we have Fanta, we have many of them here. We have Five Alive and so on, many of them. And then we have them in canned form. So these are our canned juice in Nigeria, canned drinks. So these soft drinks too, they are also liquid substances. Then look at all of them in a container. Then we have some other ones here. This is water in a glass cup. Then this is milk in a glass cup. This is a soft drink in a glass cup. So in short, liquid should always be in a container. So it's not possible to have liquid in space. It must always be in a container. There's no way we can have liquid without a container. So look at all of these. These are other examples of liquid. Then look at these ones in round bottom flask. So this is how we use them in the laboratory. Look at different colors. All of them, each one of them represents liquid. So let's consider the general properties of some liquid or some general properties of liquids. So here is the list of some general properties of liquid. So almost looking like the opposite of general properties of solid, but not exactly opposite in some cases. Let's start with the first one. Liquid are not rigid. You can see that this is opposite to solid, which are rigid. So of course, they are not rigid. They don't have rigid shape. Secondly, liquid do not have definite shape. So they don't have definite shape. So they only take the shape of their container. So it means that whatever shape their container has, so that's the shape that they will assume. If the container is cylindrical in shape, then the liquid too will be cylindrical. If it is spherical, the liquid will be spherical. If it is cuboidal, if it is cube, so the liquid inside will also be a cube. Next, we have liquid have definite volume. Of course, we can measure the volume. We can even measure the volume with several instruments. We can use measuring cylinder. We can use round bottom flask. We can use pipette, burette, and many other laboratory equipment. Now, next, the particles of liquid are loosely packed. I have to correct. So the particles of liquid are loosely packed. Even though there is no space between them, if you look at the surface of water, you see that you can't see any space in between the particles or the molecules of the water. But with that, they are still close together. Even though the closeness is loose, it's not as strong as that of solid. Then we move to the force of attraction between the particles of liquid is weak. Of course, it's weak. And that's even why the molecules of liquid can flow on top of a solid surface, and they have higher kinetic energy than those of solid. So I've explained property 5 and property 6 together. That's why they are free to move, because their binding force is not as strong as those of solid. Then we have liquid diffuse slowly and can evaporate if placed in an open container. Of course, that diffusion is also due to the weak force of attraction between them. And then they can evaporate because they are very free. They are free to move. So then we have liquid are not compressible. Of course, if the liquid is more than the container, it will not contain. We can't force the liquid to enter into the container. It can only take the container can only take some amount of liquid that is equal to its volume. So the other liquid cannot be compressed forcefully into it. That's why liquid are also generally not compressible. So now let's move to the properties of gas. Let's consider gas. Now consider each of these images that we have here. So if you look at the first two, you will see that these are smoke. The first one here is smoke, and this is another smoke. They are examples of gas. And then what we have here is the gas cylinder. So the cooking gas that you use at home, which is called LPG, that's liquefied petroleum gas. So LPG, liquefied petroleum gas. So that's in form of liquid. So it's always filled here. This is a source of gas also. It can be butane and it can be propane. So that's what we use in cooking at home. So look at several other examples of gases here. The air that we breathe in is a gas. The atmosphere itself is a gas. The carbon dioxide that we breathe out is a gas. Helium is a gas. We have ozone layer at the upper part of the atmosphere, which helps us to prevent the ultraviolet ray of the sun. So that's also a gas. The water vapor in the atmosphere is also a gas, which then steam that comes out when water has reached its boiling point is also a gas. We have several other examples of gas. Nitrogen is a gas. We have chlorine gas, and we have ammonia gas. We have many other that we cannot even mention. So we have the natural gas, many other. So gases have general properties which are very much different from the properties of both solid and liquid. So now here is the list of some general properties of gases. The first one is gases are not rigid, of course. So they are not rigid at all. You can see how they are very, very weak. They can travel very fast and cover very wide range. And after some time, they disappear. You won't even see them again. Then next, gases do not have definite shape. So they fill up their entire container. This is also true about gas. So they don't even assume any shape. They will fill up their entire container. Third, they do not have definite volume. So no definite volume for them because they will take the whole container. Next, the particles of gases are very loose, of course, because they are not even holding one another. It's just as if there is no force of attraction between them. So that's why the next property says the force of attraction between the particles of gases is negligible. So that is, it's something we can just neglect, as if there is no force between them. That's why they are not holding one another. So they can travel very fast and cover a wide range. So the particles of gases can travel very fast. So due to their negligible binding force, hence they are said to have highest kinetic energy. So this is also true about them. Because of their high speed and lack of strong binding force, they have high kinetic energy. It means they can travel very fast. Next, gases diffuse very fast. So that is the rate of diffusion in gas is the highest. It's very high. And finally, gases are very compressible. No matter how small the container is, you can squeeze gas into the container. So that's why gas is so much different from solid and liquid. Thank you for viewing this. God bless.